Hello dear students and welcome to my YouTube channel. In this video we are going to look at a question which was asked in GATE 2009. It is question number 21 carrying 2 marks. We are given a 3 by 3 matrix which is a lower triangular matrix and we are interested in the trace of a power 102 and there are 4 options provided to us. This problem is a mixture of linear algebra dealing specifically with eigenvalues and eigenvectors along with complex numbers. So let's begin. So first of all, we can see that A is a lower triangular matrix or simply a triangular matrix. This implies its eigenvalues are the diagonal entries. So we have the 3 eigenvalues which are placed on the diagonal. So we can say that lambda 1 is equal to 1, lambda 2 is equal to negative 1 plus I root 3 over 2 and lambda 3 is equal to negative 1 minus I root 3 over 2 are the eigenvalues of A. Since we are interested in the trace, so let me tell you that the trace of a matrix A is nothing but sum of its eigenvalues. So in this case, since we have got the 3 eigenvalues to be lambda 1, lambda 2, lambda 3, trace of A will be lambda 1 plus lambda 2 plus lambda 3. And we are also going to apply the same result to find out the trace of A raised to 102. So for that, we will be needing the eigenvalues of A raised to 102. So for that, again, we will take help of a result. Since the eigenvalues of A are lambda 1, lambda 2 and lambda 3, the eigenvalues of A raised to 102, they are going to be lambda 1 raised to 102, lambda 2 raised to 102 and lambda 3 raised to 102. So it's not difficult to see that these eigenvalues are 1, then lambda 2 raised to 102 is going to be negative 1 plus I root 3 over 2 raised to 102 and lambda 3 is going to be negative 1 minus I root 3 over 2 raised to 102. In the beginning, we discussed that this is a mixture of complex as well. So here you can see that we are interested in the 102nd power of this complex number of both the complex numbers. We are going to take help of the polar form of the complex number and also the de Moivre's theorem. So let's talk about lambda 2 first. So say consider lambda 2 is equal to negative 1 plus I root 3 over 2. Now over here we can see that the real part is negative half while the imaginary part is root 3 over 2. So we can find out R, which is evaluated as square root of x square plus y square. In this case it is going to be square root of negative half square plus root 3 over 2 square and this is going to give us 1. So we have got R and we'll also need a theta. So theta is given as tan inverse of y over x. So that is going to be tan inverse of root of 3 over 2 divided by negative half. So this reduces to tan inverse of root 3 with a negative sign. Now, if you will observe that x is negative and y is positive, so we do understand that this coordinate or this complex number is going to lie in the second quadrant. And in the second quadrant, the tan inverse of negative root 3 is given as pi minus tan inverse of root 3, which is going to be pi minus pi by 3, and that's going to be 2 pi over 3. So we have the value of R, which is 1, and we also have the value of theta, that's 2 pi by 3. So we are going to take help of these two values and rewrite the complex number lambda 2. So we can say that lambda 2 is equal to, as per the general formula, it is going to be R into cos theta plus I sin theta. So that makes it r is 1, so we can avoid writing that. We'll be having here 2 pi by 3 plus I times sine of 2 pi by 3. For the next part, since we need the 102th power of lambda 2, so this is going to be cos of 2 pi by 3 plus I times sine of 2 pi by 3 raised to 102. Now we'll apply the de Moivre's theorem here. So by the application of de Moivre's theorem, which says that for any integer n, cos theta plus I sin theta raised to n is equal to cos of n theta plus I times sine of n theta. And this theorem actually holds for any rational value of n as well. So now bringing 102 and we'll be multiplying it with the argument. So we need to do 102 times 2 pi by 3. And over here again, we will be doing 102 times 2 pi by 3. So we have certain reduction and this results in cos of 68 pi plus I times sine of 68 pi. And we'll just mark this equation because we'll be needing this. And this is equal to, now since it is cos of 68 pi, it will reduce to cos of 0, which is 1, and I times sine of 68 pi is going to be I times 0. So we get the value for lambda 2 raised to 102. Now since lambda 2 and lambda 3, they are complex conjugates of each other. So we can directly write down its polar form as lambda 3 is equal to cos of 2 pi over 3 minus I times sine of 2 pi over 3. We are using this expression for lambda 2. And for the next part, taking the 102nd power, so we'll be getting lambda 3 raised to 102 is equal to cos of 68 pi minus I times sine of 68 pi, and this is again going to be 1. Thus we have got all three eigenvalues of a raised to 102. So the first one being 1, the second one being 1 again, and the third one being 1 again. So thus we can finally come to the conclusion. So we can say that trace of a raised to 102 is the sum of lambda 1 raised to 102 plus lambda 2 raised to 102 plus lambda 3 raised to 102, and that's going to be 1 plus 1 plus 1, which is equal to 3. So thus option D is the correct answer. I hope this video helps you. Do consider liking and subscribing to my channel, and also press the bell icon to get notified about the upcoming videos, and also share it with your friends who are preparing for similar type of courses, including IIT JAM and GATE as well. Thank you so much for watching till here, and happy learning.